purposely, some of the worst things in math are zeros and negatives, right? This always messes up. So there's a negative in here you have to be very careful about. So what do you guys do first here? Good. So in this case, there's nothing inside I can do, but then I kind of take a step out and say, now I'm going to think about distributing. So be careful here. What am I distributing into here? Negative 2. So here's 6. What's negative 2 times x? And what's negative 2 times negative 4? Plus 8. Good. Are you guys with me? No, I don't like that. That's all right. I mean, if you're not, be honest. So is everybody cool with that? You guys see that? So let me focus on that for a second. Let me show you a different way to look at this. Let me put a number out here just for now. If you just bring the 2 in, isn't the minus still out here? So if you just bring the 2 in, it'll be 2 times x is 2x. 2 times negative 4 is negative 8. You still have a negative that has to go in there. 4 minus 2x is 4 minus 2x minus negative 8 is plus 8. So I'd rather, instead of doing 2 steps, I'd rather say, okay, there's a negative 2 times x is negative 2x, negative 2 times negative 4 plus 8. But this is the easiest mistake to make. I see it all the time, almost no matter what level of math I teach. Somewhere somebody makes this mistake. Negatives do that to us. But you really have to realize that negative is a part of this. It goes through. Because how could you rewrite 6 minus 2 something? You can rewrite it as 6 plus negative 2. Remember that? So isn't that really a negative 2 then? That's going in? Hell yeah. Touche. And then over here, what do you get?
24.
Good. Plus 24 minus 6x. And now you do like terms. Right? So distributive property very often is the first step I do in an expression or an equation, and then I start combining things.
6.
Yeah, 6, 8, 24. 6 and 24 is 30 plus 8, 38. Yeah, minus 2x, minus 6x, minus 8x. Cool. Not an equation, so you can't solve for x. How you guys doing so far? Is that be honest now. Right. Real quick too, I don't know if I've said this yet. If you really are having trouble with something I'm doing on the board and you kind of look around before you say anything and everybody next to you is kind of like shaking their head, they're doing that for my benefit very often, I've noticed. They don't really maybe understand it, they're just shaking their head, so I'll think they understand it. I'm like, that doesn't make any sense to me. So if you speak up and you ask a question, probably 8 other people have the same question, and you are their hero because they don't want to speak up. Yeah?
So if in front of the parenthesis, if you only had negative, you didn't have any of those numbers?
Ah, yeah. That's the most evil situation. And that's where actually putting the 1 helps too. Yeah. So if I had a problem like this, negative 5 minus 3x plus 6x. What's in front of here, understood to be here, if you want to, if that helps, you could put a 1 there, right? So you do have a negative 1 going in. So what's negative 1 times 5? And what's negative 1 times negative 3x? Plus 3x, I love it. So that's cool, that's fine. Good, so this guy's all by himself. These two go together. Do not make that 4x. That's another easy thing to do, right? When you start doing a lot of these, those are not like terms, you can't put them together. Okay, Piston right. So, let me show you one more thing and then give you several to try out of the little blue book. So hopefully most of you have it with you. We'll see. Coming back to equations. Let me start off with the question somebody had earlier. Now we haven't, there's one of the bonus section of the test like this. We haven't seen one like that yet really in what we've done. So what's wrong with this as far as what we know our goal is? Remind me what our goal is. X is on one side, numbers on the other side. So you see how you get to pick now. You just want the x's on one side. Which side? I really don't care. Which side do you want to put the x's on?
7x minus x.
So, okay. So either I need to do what? I need to kill this guy, so I need to do what to kill him? Subtract 3x. Or I want to kill him, so I subtract 7x. Now do you realize, let me point this out. If you subtract 7x, won't that leave a negative over here?
Yeah.
Yes.
So, and some people, and I understand this, negatives kind of trip us up sometimes. So I kind of always go where it's going to stay positive. So I want to make sure everybody's with me now. Both sides have x's. That's not our goal. I want one side's x's to go away. So if I kill this guy's x's, how do I do that? Yeah, minus 3x. That'll be one step closer to my goal of figuring out what the hell is x. So on this side I get nothing there, good. Negative 11 equals, good. This is 4x plus 9.
Minus 3, so 4x.
In the terms of these equations, would it be wrong to say that you always subtract the lesser of like the x or whatever? Because that's what I've noticed. That
You don't have to, but what that does for you is it keeps this positive.
okay.
Cool. Alright, so far so good. Now, let me ask you this. If I want to get x by itself, and I start to think, let me kill that 4, why do I not currently want to divide by 4? Because then I make fractions, don't I? And I really want to stay away from those if I can. We're going to go into them. We should be able to handle them if we have to, but if I don't have to, why would I? It only makes sense. That's where I make more mistakes, so let me stay away from that. So I almost always divide last. Whatever's still with the x at the end, I divide and kill that piece. That's the very last thing I do. So if I do get a fraction, I'm done. I don't care. That's the answer. Right? But what do I do now? I move the x's this way, so they're all together. Who's not in the right place right now? The 9's not in the right place. I want the numbers on one side, leave the poor x's alone, right? So how do I kill that 9?
Minus 3.
Yeah, minus 9.
Minus 3.
Good. Negative 11 minus 9, negative 20 equals 4x, and this is gone. Beautiful. So the last thing, like I just said, is almost always divide. You divide by 4. So you get x by itself. Negative 5 equals x. Any questions about that specific one? We're going to do a couple more like that. Yeah.
What did we just do with the negative 9? I'm sorry, I totally spaced out right now.
That's all right. Right there, there was a 9 with the 4x, but I want the x's by themselves. So how do I kill that 9? I subtract it. Whatever you do to one side, I better do to the other side. So it still is true. You with me? So keep in mind that 5 plus 1 equals 6. If I subtract 1, I better do it to both sides, or else my equation is not true anymore. And of course, that majorly sucks. I want a true equation. How could I check this?
Plug it in.
All right, so let's try it. Check. X equals negative 5. So 3 times negative 5 minus 11 equals, I'm not sure yet, 7 times negative 5 plus 9. Right? It's kind of nice. You got to realize, not everything you can check to make sure you got the right. In history, if you answer what happened in this year, can you check that somehow? You know, let me Google it. No, you can't. There's no way to check. Math, you can actually check. I got an answer. Let me see if it actually is the right answer. Sweet. You can't do that with everything. What do you get here? Negative 15 minus 11 is negative 26. And over there, Good, negative 35 plus 9. Thankfully is negative 26. Check. So x equals negative 5 is the answer. Tickle. All right, so try this one. Real quick, one thing about anybody else not get their test back? You can make corrections to that just like the quiz. What's that?
Solve it
Oh yeah.
for X.
Oh yeah. Now, real quick, I think I've told you this before. There are websites that will solve that kind of problem for you. It will show you the steps. Homework is not worth it. I really want you to understand. Homework is worth a part of your grade, but not a very large part of your grade. So it's not worth it. If you get a perfect homework grade because you copied everything off of a website, how are you going to do on the tests? You're going to die. And those are worth a lot more. So it never makes sense to me that people would do that. Anyway, what do you guys do first here? Because you could either add 3x or subtract 11x, but if I add 3x, it stays positive, right? I want to make sure you understand, it's not wrong if you subtract 11x. It's just a little easier if I don't. So we add 3x. And of course, we're doing that so we get our x's together. I want to gather them all together. Those go away. 8 equals, good. So 14x. Now I'm really trying to show you guys that where people make the most mistakes is when I have somebody that does something like this, and then they kind of, in their head, they do this, and then I don't even see an equal sign anymore. And then the 20 comes over here, and they lose track of what's going on. You start to move stuff to the other side without even realizing you did it. So you have to be tell yourself, this is this side, that's that side. Right, just bring everything along with the running. What's the next thing I do? I got all my x's together. Yeah, I want to kill that 20 over there. The negative 20, so I add 20. Good, 28. 14x. You almost always divide last. You want to kill the 14. 2 equals. I like the emphasis.
Congratulations. Yeah.
All right, so here's the next level, and then I'll let you guys try a few out from the blue book. I think I did something else. Aw. The more you say that, the more I get.
No, that's what I said.
So be careful. not even gonna make it necessarily come out nice. Now, let me just say this. I think most of you guys do this. Realize a couple things, like I said. The equal sign breaks it into sides. So you can work with one side and the other side. Which side requires work right now?
The first side.
Yeah, the first side. Your eyes then gravitate towards the parentheses. And in this case, it's not because you want to do inside, because you can't do anything in there. It's because you want to distribute that for you. All right, cool. So go ahead. Start attacking this thing. Just make sure nobody's done this. This is not 7. Because what do you have to do first? Distribute, because that's the multiplication step. Good. Yeah.
I'll tell you what, right there, what you want to do is make sure both sides are simplified before you start moving stuff out. Because then it's going to look a lot more like that last one.
Number x's equals number x's.
So if I put the 4 and 15 together.
So I don't want to do it.
You could do that.
So like right here, that's basically what it is.
That's fine so far, and then I can put the 4 and 15 together.
Right.
Yeah.
I like it. And then the last step.
You don't have to, you just make a fraction. That's like I said earlier, it doesn't matter if you end up with a fraction because you're done. It'll make it difficult to check plugging a fraction back in all the time. But, what do you think about what the number is? How would you get x by itself? Divide by -2. And then the fraction makes that number. Do that to both sides. Oh, wait.
Oh, it was 4 plus 15. Yeah.
What's the last step? Yeah, as I was making it, I was saying, I said, I'm not gonna make this come out nice. Right? But you're done, one more step. Don't worry about what the number is. I'll look at the x by itself. Divide it. Just a fraction.
So she's gonna be like that?
Oh, right there. You subtracted 4.
Oh, okay.
Yes. So you should be ending up with fractions. So make sure you understand. Don't make it a decimal. Don't start long dividing it. Just leave it.
It's up to you. You can pick which way you want to go. Pick 4 or 5. Sure.
What are you gonna do, sorry? Good.
Sure. X equal 5.
No, careful. You did 19 minus 4. You're supposed to do 19 plus 4. Careful. All right, so let's do this. So the first thing I do, right? So 4 plus 6x plus 15. And now let me get you guys in the habit of this. It's not wrong to not do this, but you should simplify both sides as much as you can. This side, nothing I can do. This side, I can combine 4 and 15. So I get 6x plus 19. Now doesn't that look a lot like the kind of problems you were just doing a minute ago? You almost always hit this step where you decide which way to take your x's, which way to take your numbers. So which way do you want to take your x's? Yeah, -3, I like it.
Yeah.
So that they stay positive. If you subtract 6, you're not wrong. You're just going to have a negative in there you got to be careful about. So -3x, -3x. Those go away? Yes, ma'am.
I don't know why, but I added 4 to 19 and 4.
Yeah.
Yeah,
Yeah, that's what I did too.
15 and 4. So I'm going to add 4 eventually, yes.
Why do you add 4?
So does
To
it
kill
matter?
this. Well, not add 4, I'm sorry. I'm going to bring the 19 over to the 4.
The
Yeah.
first one.
So, all right, let me stop. So there are many different ways. You could subtract the x's the other way. You could make the 19 later. You can never make the 19. You could actually subtract 4 right now if you wanted to. There's a lot of different ways as long as you're killing something on one side and doing the same thing to the other side. There are a lot of ways to get to the answer. I'm trying to show you something you can do for every single problem. Simplify one side, simplify the other side, and then pick where to move your x's, and then move your numbers the other way. That's a standard operating procedure if you want that to be that way. Cool? But there's a lot of different ways to do this problem, there is. So not everybody's looks like this. But you should start to see the same numbers popping out of here as what you had on yours. So I subtracted 3x from both sides. Probably what most of you guys did. So I got my 3x plus 19. Good? Right? Now my numbers are in the wrong place. Those guys need to be over there. Minus 19. So I still have 3x equals negative 23. And this is where people freak out, but this tells you what to do, not that. I don't care what the hell number that, I don't care. That could be 18 billion.7. I don't care. What's this side tell me to do? Divide by 3. So some of you guys got to a point where you divide